In this lesson, we're going to look at adding radicals. To add radicals, we're going to first understand the common terms used in radical expressions, and then we're also going to look at the steps that we follow to add radicals. Now look at the common terms. So the radicals have common terms if the radicand are the same and the degree of the radical are the same after simplifying the radicands. So the radicand, if you have a radical that looks like this, square root of 2, the radicand is the number under the square root sign. So for us to figure out if two radicals have common terms, we need to first simplify them. I prefer to use the factor tree method to simplify. So if I have 18, for example, I have 2 and 9, 3 and 3, and for 8, I have 2 and 4, 2 and 2. So the square root of 18 is the same as the square root of 2 multiplied by the square root of 9, which is going to give us 3 square root of 2, and the square root of 8 is the square root of 2 multiplied by the square root of 4, which is going to give us 2 square root of 2. So if you look at 18 is 3 square root of 2, 8 is 2 square root of 2. So you can see that the radicand are the same. So we can easily say, and also the degree is 2 for both of them. So we can say that 18 and 8 have common terms. So square root of 18 and square root of 8 have common terms. So that's really the process you follow to determine if radicals have common terms. Now let's try this example. Look at 27. We have 3 and 9, and then 3 and 3. We'll look at 32. We have 2 and 16, 2 and 8, 2 and 4, and then 2 and 2. So 27 is the same as 3, or square root of 27 is the same as square root of 3 multiplied by square root of 9, which is going to give us 3 square root of 3. 32 square root of that is the same as square root of 2 multiplied by square root of 4 multiplied by square root of 4, which is 2 times 2 square root of 2, which is 4 square root of 2. So 27 square root of 27 is 3 square root of 3, and square root of 32 is 4 square root of 2. So because the radicand are different, these do not have common terms. Now we move over to this. The cube root of 16, go through 16, 2 and 8, 2 and 4, 2 and 2, and then 32. 32 we have 2 and 16. For 16 we have 2 and 8. For 8 we have 2 and 4. And then for 4 we have 2 and 2. So the cube root of 16 is going to be the cube root of 2. The cube root of 2 multiplied by the cube root of 8, which is going to give us 2 and then cube root of 2. The cube root of 32 is going to give us the cube root of 4 multiplied by the cube root of 8. So this is going to give us 2 and then cube root of 4. So now cube root of 16. So cube root of 16 is 2 cube root of 2. Cube root of 32 is 2 cube root of 4. We can see here that the radicands are very different, so these two do not have common terms. So now let's look at adding radicals. We want to group common radicals together and then we add the coefficients. So in this case, these are common radicals because we have the same radical. And so this is going to be, because there is no coefficient in front of the square root of 6, we're going to use 1 square root of 6 plus 3 square root of 6. So because we have the same radical, we can have 1 plus 3 square root of 6, which is going to give us 4 square root of 6. Now, in this case, we don't have the same radicand, so we're going to simplify each of these terms. So we'll look at decomposing 12, 2 and 6, 2 and 3, and 27, we decompose that to 3 and 9, 3 and 3. So we replace square root of 12 with, because we have a pair here, so it's going to be 2 square root of 3 plus 3, and then square root of 27, we have a pair of 3's here, so we're going to multiply by 3 square root of 3. So this expression now becomes 2 square root of 3 plus 9 square root of 3. So we have the same radical here, so we have common terms. So it's going to give us 2 plus 9 square root of 3, which is 11 square root of 3. We're going to do the same thing here, but we have to simplify each of these radicals. So look at 80. We have 240, and then we decompose 40 to 2 and 20. 20 becomes 2 and 10, and 10 becomes 2 and 5. Let's look at 45. We have 3 and 15, and then 15 becomes 3 and 5, and then 125. We decompose this to 5 and 25, and then 5 and 5. So now we're going to rewrite this expression, square root of 80. So we have a pair here, and then we also have another pair here. So we have 4 square root of 5, and then 3, and so we have 45 is, we have a pair of 3's. This is times 3 square root of 5 plus 5 square root of 5. So let's simplify before we add. So this is 4 square root of 5 plus 3 times 3 is 9 square root of 5 plus 5 square root of 5. So we have 4 plus 9. Because we have the same radical here, we have common terms. So 4 plus 9 plus 5 square root of 5. This is going to give us 18 square root of 5. Now we're going to look at square root, the cube root of 16. So let's use our factor trees again. 2, 8, 2, 4, 2, 2, and then we have 54, 2, 27, 3, 9, 3, 3. So 16. So we're going to replace the cube root of 16 with, so we have a group of 3 here. So this is going to give us 2 cube root of 2 plus, and then we have a group here, group of 3. It's going to give us 3 cube root of 2. So this is going to give us 2 plus 3 cube root of 2. So this gives us 5 cube root of 2. Now, finally, we're going to bring this all together. So let's look at 16. From the previous video, we can see that 16 is 2 cube root of 2, and 54 is 3 cube root of 2. So let's look at 8, 2, 4, 2, 2. So 8 is 2 square root of 2, and 32, we have 2 and 16, 2 and 8, 2 and 4, 2 and 2. So we have a group here, a group here. So this is going to give us 4 square root of 2. So now we're going to group common terms together. So we can see these are common, and then these two are common here. So the ones with the cube root are common, the ones with the square root are common, because they have the same radicand, which is the number under the square root sign. So now we have 2 plus 3 square root of, rather, cube root of 2 plus 2 plus 4 square root of 2. So we end up with 5 cube root of 2 plus 6 square root of 2. So this is how you deal with adding radicals.